Are you ready to really level up your Java skills? I mean, if you've been messing around with simple data types and you're ready to build more organized, real-world applications, then you're in the right place. Today, we're going to dive into arrays of objects, and trust me, this is a concept that will fundamentally change how you write code. So here's our game plan. We're going to start with a quick array refresher, just to get warmed up. Then we'll run into a really common coding problem and see how arrays of objects offer this beautiful, elegant solution. We are absolutely going to tackle a major misconception that trips up so many developers. And finally, we'll put it all together and wrap up with the key takeaways that'll stick with you long after we're done here. All right, let's start at the beginning. Before we jump into the deep end with arrays of objects, let's do a quick review of a basic array concept, and more importantly, a classic trap we all need to know how to avoid. You know, when you're just starting out, you see this all the time. We write these neat little loops with a hard-coded number, like 7, as the limit. And hey, it might work at first, but this is a really risky habit that can lead to some nasty program-crashing errors down the road. So just think about it for a second. What do you think happens if your loop is trying to run 7 times, but your array only has 6 spots in it? Indexed 0 through 5. What's the hidden danger here? And here's the culprit: the array index out of bounds exception. This is probably one of the most common errors for new Java programmers, and it's a tricky one. See, your code will compile just fine, no warnings. But the moment you run the program, bam, it crashes. It's like asking your code to check a mailbox that doesn't exist. It just breaks. Luckily for us, Java gives us a much safer, much more professional way to handle this. Instead of hard coding a number, you just use the array's built-in .length property. This makes your loop totally dynamic and basically foolproof because it always knows the exact size of your array. This isn't just a suggestion. It's the standard, non-negotiable way to write robust code. Okay, with that under our belts, we've mastered safe looping. Now, let's take this to the next level. How do we manage data that's more complex than just a list of numbers, like, say, a bunch of student records? So imagine you have a student class. If you need to store data for just a few students, you might do this, right? Create individual objects, S1, S2, S3. But you can probably already see where this is going. Even with just 3, it's getting repetitive and a little messy. And yeah, that's the real issue. 3 students? Fine. But what about a class with 30 students? Or an entire school with 3,000? There's just no way you're going to create thousands of individual variables. It's not scalable. We need a better system. And this is where our elegant, scalable solution comes in. The answer to managing a huge number of related objects is the array of objects. Now, this single line of code right here, this is the key. It's going to unlock a whole new level of organization in your programs. It might look kind of familiar, but it's incredibly powerful. We're not just making an array for numbers anymore, we're making one that holds entire student objects. Let's break down exactly what this thing is doing. First up, student array. This part declares the type. Think of it like a special kind of box. This box is specifically designed to hold only student objects. You can't just throw a car object or a string in here. Nope, it's custom built for students. Next, we have students. Super simple. This is just what we decided to call our array. We could have called it student list or class roster, whatever, but students is nice and clear. It tells us exactly what's inside. And finally, the most important part, new student 3. This is what actually builds the thing in your computer's memory. So let's use an analogy. This line is like going out and buying a brand new filing cabinet with 3 empty drawers. Each drawer is perfectly sized and has a label on it that says student file here. Now hold on. Before we go any further, we absolutely have to talk about the single biggest point of confusion for pretty much everyone learning this. This is so important. It's all about what that last line of code doesn't do. So let me ask you directly. When you type new student 3, does that line of code actually go ahead and create 3 brand new student objects for you, all ready to go? The answer is a huge, emphatic no. And you have to burn this into your brain. That line only creates the container. It builds the filing cabinet, but the drawers are completely, totally empty. Right now, inside each of those 3 slots is the value null, which literally just means nothing. We have the cabinet, but we haven't made any files to put inside it yet. So here's the correct way to do it, is a 3-step process. Step 1, you build the filing cabinet by creating the array.
Step 2, you create the actual files by making your individual students objects. And step 3, you put the files into the cabinet by assigning those objects to the different slots or indices in your array. Excellent. So now we've correctly built our array, and we've actually put our student objects inside. So how do we get that information back out? Let's put it all together. Well, we use a for loop. And hey, look at that, we're using .length to be safe. Now, inside the loop, the part that says student's I, that grabs the entire student object from whatever position we're at. Once we have that object, we can just use the good old dot operator to get its specific properties, like .name or .marks. It's a two-step dance. First, get the object from the array, then get the property from the object. Wow, we have covered a lot of ground, right? We went from a simple coding problem all the way to a really powerful solution. So let's wrap this up and lock in the most important points so this stuff really sticks. Here's a quick little cheat sheet for you. To declare and create that container, you use this syntax here. To assign a new object into one of the slots, you use its index. And to get data back out, you combine the index and the dot operator. Keep this handy while you're practicing. All right, let's review the crucial takeaways. First, always use .length in your loops. It's just a non-negotiable best practice. Second, arrays of objects are your best friend for organizing complex data. And third, and if you remember one thing, make it this one. Creating the array only creates the container full of nulls. You still have to create the actual objects to put inside. And this isn't just some academic exercise. This is exactly how you handle real-world data, like stuff you pull from a database. And I'll leave you with a little challenge to think about. We know how to get a student's name or their marks one piece at a time. But what if you wanted to print all of a student's details at once, really cleanly, just by printing the object itself? Is there a built-in Java way to do that? That's a great puzzle to think about for next time. Thanks for joining me.